Hi everyone, welcome to Reaching for the Moon. This is a video of a lecture that I gave at the United Church of Marco, titled Voyage to Mars. Thanks to Hannah Chappell, the IT director of the church, who recorded the video.
Thank you. Thank you everyone for coming. Everybody want to take a trip to Mars today? Yeah, I'm ready. My name is Ed Grace. This is my wife, Sandy. During the presentation, if you've got a question, raise your hand. We'll try to do it. We'll try to answer them right when you have versus we'll have time afterwards. But if you have one relating to what we're talking about, let's answer it there. I spent 10 years working on the Apollo program. MIT had a contract with NASA to design the inertial navigation system, which was used on both the lunar module and the command module. It included the flight computer. We designed the flight computer, we programmed it, and trained the astronauts how to fly the lunar module and the command module. We didn't know ourselves, but we taught them how to do it. And by the way, we went to the moon and back with a computer that had 32K of memory. You can't turn your cell phone on or off today with that much memory. Every mission had different software, and likewise, the lunar module had different software than the command module, even though they're the same computer. As Russ said, I personally happened to, I worked in Cambridge, Massachusetts at MIT, but during the missions, I would go to Houston to be in a backup control room. So I was in Houston for Apollo 11 mission, landing on the moon, and Apollo 13 when we got the astronauts back. I'd like to start off with just a video from NASA, just to get us in the mood of space travel. We've got to start thinking space. So this is a quick video clip.
We're never going to stop exploring the unknown in air and space. We're not going to stop innovating for the benefit of humanity and inspiring the world through discovery.
He's our ex-senator. He's now the administrator of NASA.
It will go down in the history books as one of the most accomplished years all of NASA's history and missions. The golden age of space exploration. So much to look forward to in 23. Climate missions that will tell us about how our Earth is changing. Game-changing aeronautics developments with the 59 and the X-57, and the selection of the first astronauts to go to the moon in more than 50 years. And there's a lot more coming. There was a philosopher, a historian, someone who had a great grasp of the future named Carl Sagan, a scientist. And he said, exploration is in our nature. We began as wanderers and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars. We have set sail for the stars. Now we're going to reach out to the unreachable stars.
Okay, we're now going to get on to Mars. And here's another quick clip. I hope. What you need to know about Mars, this background. Mars is a tough place. It doesn't have very much atmosphere, and it's also a very long distance. You know, if we do have aliens that come visit us here on Earth, they've got way better technology than we have, because we don't have the technology yet that we can go there. I mean, distance to get from here to Mars, as we're going to see in a second, is about 7 months, and 7 months back, it's a long trip. NASA has put a total of 5 rovers on the surface of Mars. Back in 1997, the Sojourner, it only worked for about 90 days. And but it gave us our first pictures, our first feel into Mars. In 2004, we launched actually a pair. These two went up together, and one of them operated for about till 2010, the second one went to 2018. In 2012, we put the Curiosity rover on surface. It's still operating. So here we are, which is 11 years later, and it's still going well. Just recently, 3 agencies launched rovers or missions to go to Mars. And they all the missions were launched in July of 2020. Now, why do we launch in July of 2020? This is a picture of Perseverance, which was NASA's vehicle, and which is now up on Mars' surface. The United Arab Emirates launched what they call the Hope probe, and it was an orbiter. There was no rover, no lander, and it was launched on 2020. Its purpose was to study the Martian surface and its mineral composition, and it's still in orbit today doing its job. China launched the Taiwan-1, again back in July of 2020. It included 3 items: an orbiter, which is orbiting around Mars, a lander which landed on the Mars surface, and on top of the lander was a rover, the Zuhrong rover. NASA launched Perseverance also in July of 2020, and it likewise is now on Mars, but it included a helicopter, a little 7-pound helicopter that became the first vehicle to actually fly in a foreign soil. Why all the launches at the same time? Actually, there was supposed to be a fourth launch. European Space Agency, ESA, they were scheduled to launch also a rover to Mars at the same time. However, that was the pandemic time, and they got behind schedule. It got postponed, and it was being done jointly with Russia. The European Space Agency subsequently has canceled the plans for that rover. Why all at the same time? Well, we have what we call Mars Opposition Day. And this is the sun, this is the Earth, and this is Mars. As you can see, we're orbiting around the sun. Well, once a year, they get into position whereby this is the sun, this is where we would launch from Earth, and when we launch from Earth, this is where Mars will be. And as you can see, Mars only has to move from here to here. Our spaceship has to go that. That turns out to be the shortest distance. If we launch from any place else on Earth, it's going to take longer. That takes about 7 months when we launch on Opposition Day. And it's called the Hohmann transfer. This is just another showing of the same. Here was Earth at launch, here was Mars at launch, and this is where they arrived together. All three launches did make it to Mars, and all got there in February of 2021. This is a picture of the HOPE probe, and it doesn't have a lander. It's still up in orbit around Mars. It takes about 55 hours for HOPE to make one orbit of Mars. Its mission, it's there to study the Martian atmosphere, the climate, the weather. And they worked, the United Arab Republic was responsible for putting this up, but they worked with a couple of our universities. The University of Arizona was where this was put together, and UAE used Japan rockets to put it on its path to the Mars. So it was launched by a Japanese rocket. This is China's Tianwen-1, and when it got there, it spent about 90 days circling Mars. They were actually analyzing the land, where they wanted to land. So remember, they had a lander, an orbiter, a lander, and a rover. So they spent about 90 days figuring out where is the best place to put down. And the lander with the rover landed on May 14th of 2021. This is where China put their lander at Utopia Basin, and this is a closer look. You can see it's a big, wide open plain, so it was a pretty safe place to put down Zuhrong. This is a picture of their rover. This is the rover on top. This is the lander. And these are two ramps that after it landed on the surface, the Zuhrong rover came down the ramps, and it has since been exploring Mars. This is a clip from Chinese government telling you what they're doing with the rover. It's funny, in their press releases, they put out that they're working with NASA and they're working with ESA. They don't give us any information. And just that propaganda coming out, okay? Okay, here's a quick clip on Perseverance, which was NASA's launch. It also went up in July of 2020, and this is in the laboratory when they're putting it together. NASA plans to bring back, as we'll talk later, some samples from Mars, and Perseverance has been out there collecting them, and as you'll see, they've got plans to bring these samples back to Earth. Okay, Perseverance, it included this Ingenuity helicopter, and this was what the Perseverance looked like. There's a shell over the top. When we landed on Mars with Perseverance, it was a powered landing. These were descent engines that would fire right here to actually land the rover on the surface softly. And notice that on the bottom of the rover and on the top of the rover, we got some cameras. Likewise, we've got a look-up camera that was in this shield here, and a look-down camera that was in the descent stage. And this is Jezero Crater. This is where the rover Perseverance actually landed on Mars. Big flat area. This was a lake at one time, and it has subsequently dried up. And this shows you the process that went through in the landing. Here's with the heat shield, and we had separation right here, parachutes deployed. Finally, when it gets over here, you can see that here's the powered descent, which actually takes it down onto the surface of Mars, and then the lander flies away and settles down in a different part of Mars. This is mission control at JPL, and what we're going to watch is the landing of Perseverance on Mars.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration. in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Those pictures were from the cameras that were on
Heat shield
Perseverance.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Now it's on the descent stage coming down.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
This is where Perseverance actually landed on Mars. Over here is where the parachute and the back shell. This is where the descent stage ended up, and over here is where the heat stage, the heat shield, ended up. And this distance is about a mile. So, yes. Yeah, nowhere's near. It's way lighter, 1/7. As we're going to see here with the helicopter, there's hardly any atmosphere. The atmosphere is very, very thin. And so in order to make a helicopter fly, they designed a helicopter with they had to create their own uplift. So it's a double-bladed helicopter with the blades going in opposite direction because the atmosphere is so thin that they can't get enough lift. So in the design, they had to get the lift to bring it up, which you're going to see right here. This is Matt Wallace. He was in charge of Perseverance, and he had a daughter who was a gymnast. And she'd been bugging him as she was doing her gym routines and things. She wanted a camera because she wanted to take some pictures of some of the moves she was doing and things. So he finally relented, and they mounted a camera on his daughter when she was doing some of her flips and things like that. That gave him the idea that, hey, I can do this on Perseverance. So once he bought her that camera, And she brought home these pictures that showed all, her doing flips. That's how they got on Perseverance. There's his daughter doing the flips. Okay, this is a helicopter, weighs 7 pounds, not very high. The original plan for the program was that we only would use the helicopter for the first 30 days. And the reason was that Ingenuity had no communications back to Earth. Ingenuity could only communicate with the rover. So then the rover had to be used to send Ingenuity's data back. Therefore, Perseverance couldn't do any of its own research and work and driving around. So before the mission, it was planned that for the first 30 days, they'll use Perseverance communications to send Ingenuity data back to Earth. Well, Ingenuity has been so successful, they've now flown like 39 missions. And they're using Ingenuity as a scout to go out and check where they're going to send Perseverance rover. Are there any rocks in the way? Are there any holes? And it's still flying. So Ingenuity is still working and flying. This is Perseverance dropping. Ingenuity was located in the bottom. It pulled out. It just dropped Ingenuity. You can see the double blade. Simulated. Some of it is real. We're going to see when it's flying. You can see the double blades. They have to spin very fast also, much faster than a helicopter would be spinning here on Earth. This is an actual picture of Ingenuity. Took it up to a height of about 15 feet, ran around up and down a little bit and brought it back. These are actual photos from Ingenuity. There's no place closer. I said, that's the closest planet. It's the only one we even had a chance to go to. There's Perseverance again. And this is Zuhrong crater. This is, again, an artist's rendition. This is lake bed filled when it had water. It's dry today. One of the things that is going to be very important if we do travel in space, that we have to have oxygen. And there is no oxygen up on Mars. So one of the experiments that they did, they brought this little box, which they call Moxie. And it was Moxie's job to produce oxygen from the carbon dioxide that was up on Mars. And it was very successful. So it's very encouraging that going forward, we'll be able to manufacture oxygen. If we were going to do a mission to Mars, there's no way they could carry sufficient oxygen for 2 years. So we have to have the ability to make it, and this experiment was very successful. Okay, just recently, both the Zuhrong rover and Perseverance rover were put down and went to sleep. And why? Well, something similar to Observation Day. It's called Mars Solar Conjuncture. And what happened here is, as you can see, here's Earth, here's Mars, and on a straight line between them, there's a sun. Our radio signals can't go through the sun. So the radiation blocks it down. So they shut down and put them to sleep for about 30 days while the planets moved so they could actually see each other again for communications. That happens about once every 2 years, because it takes 2 years for this, 2 years for a cycle. Okay, how about an update? It's been 2 years since these rovers have been on the surface. United Arab's not on the surface, but it's been orbiting. And United Arab Republic has a website you can go to, and this shows the relationship of the Hope probe and Mars when they launched. And as you can see, they joined up here. It's now been 2 years, 940 days when I took this picture of Hope probe orbiting. And they have just changed the orbit of Hope probe. What they're going to do now is they're going to spend the next 3 or 4 months analyzing one of the small moons around Mars. So they've been very open with their data. You can go to their website. You can see where they are, what's happening. This is Zuhrong, and I'll give you an update on it. Oops. 6 months ago, it was put to sleep. And it was put to sleep because of it was winter, and the solar was not giving it sufficient power. This past week, it was the 2nd anniversary of Zuhrong being on Mars. And everyone expected that China was going to issue a press release giving us a status update of what's really going on with Zuhrong. Because Zuhrong hasn't communicated back to Earth in over 6 months now. And China did not issue any release. So there's all sorts of speculation that Zuhrong may be dead, and we may have had our last signals coming from Zuhrong. This is an update on
NASA's explorers on
Perseverance.
Mars are on the move and making new discoveries. It's a journey you can be a part of too. NASA's Curiosity rover, which has been climbing Mount Sharp since 2014, is about to drive up onto a broad, sloping surface called the Green Hue Pediment. This will allow scientists to fast forward perhaps millions of years in Mars's history and study the history of liquid water written into these different layers of rock. And Curiosity made some interesting discoveries along the way. Less than half an inch in size, This unusual feature, eroded from sedimentary rock, was cemented by mineral-rich groundwater. And check out this rock, smoothly eroded by winds. Over in Jezero Crater, the Perseverance rover is getting ready for a new destination and science campaign. And it's consistently setting driving records on Mars by relying more on self-driving software that allows the rover to avoid obstacles without having to consult a human on Earth. Perseverance will be pushing north in an area where an ancient river flowed into a body of water. It left sediments in a shape called a delta. The rover will collect more rock samples there. The Ingenuity Mars helicopter will support Perseverance's upcoming science campaign. The helicopter has been given the green light to try to keep flying on Mars for the next few months. Upgrades to its navigation software will improve flight and operational safety. The Mars explorers will document the journey along the way, and you can make your own discoveries. Visit the raw image pages to see the latest images every day, and vote for your favorites. To get the latest updates, follow @NASAJPL and @NASA Mars on social media, or
Ingenuity, as I said, has now had about 37 or 39 flights, and they plan to keep going. Most of these rovers that those NASA's put up, they've really lasted a lot longer and operated a lot longer than they were designed for. I mean, Curiosity is still running. We don't know how long Perseverance is going to go, but NASA's been following. This is on Curiosity, which has been up there 10 years, but you can see what has happened to its wheels. And those are metal tires, and NASA's been monitoring this, and you can see that there's been some serious damage done to them. Matter of fact, they redesigned the tires or the wheels that are going to be used on Perseverance. So Perseverance, instead of, as you see this, it's got, and it's also a little different material. So they modified the material and the actual design. So far, the Perseverance is not showing any real bad signs of deterioration, but it's only been there 2 years. Curiosity's been there 10 years. Okay, what I've got here now is some, we're going to take some different images and pictures that Perseverance has taken on the Mars surface. You can go there, you can go to Perseverance or NASA's website, and they update every day. They put new pictures out there that have come from both the Curiosity and Perseverance rover. We've got some real innovative marketing people at NASA. As you can see, dark rocks, light rocks, holy rocks. And regolith, that's really dust. It's sort of like a little fine sand. Way more than you want to hear. Again, I've got a bunch of pictures here of Mars surface. So it's unreal. I mean, when you see the real pictures, and NASA is taking these photos, and even though it's taking stills, they're putting them together to create these panorama views. It's unreal. And these are actual. I mean, this is not doctored, or if you go on YouTube and you want to search for videos from Mars or something. I mean, you'll find videos up there showing bodies and animals. All been doctored, okay? NASA's are not doctored. These are the actual photos. Pretty color. Again, this is a panorama of Perseverance tires. Okay, as we said, NASA is planning to, Perseverance is out collecting some soil samples. And it's NASA's plans in the near future. What's the near future? 5 or 10 years of sending another mission to Mars where they're going to collect and pick up the samples that Perseverance is laying on the ground. These are some of the sample tubes that Perseverance has collected by just drilling and boring in the surface, and then it's got these empty tubes that it's putting it in, dropping them right on the surface. What I have here now is an animated, this is not real, an animated rendition of the mission that NASA hopes to have in the next couple of years. Rover's going to go. Their rover is going to go out and pick up these samples, store them, from the lander. They'll launch and come back to Earth. Point out, with the atmosphere being as thin as it is, they don't need a big rocket to launch and get back to Earth. All right, with that, we're going to well, they'll land at some place, and then somebody will go out and pick up the. Oh well, they'll have to have something that can bring it back through the atmosphere. So they'll have a heat shield, and what is going to happen is, it doesn't show on here, but if I was designing it, the rocket that they launch from Mars will probably dock with a version of one of our spacecraft, Orion or something that's out in space already, that can re-enter into our atmosphere. So, all right, with that, we're going to wrap up our trip to Mars. And we're going to talk about, we got another clip here, which is really the space race, what's going on, and give you a quick update on where we are in space today.
putting a coda on a year of space triumphs, those stunning images from the James Webb Telescope, forcing a rethink of the vastness of our universe and whether we're alone.
In the next 10, 20, 30 years, we're going to have data that's really relevant to this question. We could have an answer about whether or not there's life in the universe.
Splashdown.
2022 brought splashdown for Orion after a 25-day Artemis mission to orbit the moon. A shakedown flight before a human crew orbits the moon, then lands on the moon in 2025 or 26.
I can bounce gently in this spacesuit and not very unlike what I can do on Earth.
At a NASA training pool with sand and rocks on the bottom, astronauts are already practicing future moonwalks.
This is very similar to what the Apollo astronauts did in preparation for their missions to the moon.
They've got to try to replicate what it's like on the south pole of the moon, where the sun is very low, right in your eyesight, but everywhere else, it's pitch black. NASA wants to land on the South Pole, where there are signs of ice, potential drinking water, and most importantly, rocket fuel. Meanwhile, after years of setbacks, Boeing is hoping to finally launch its Starliner spaceship, which will carry astronauts to the space station in April, as Elon Musk's SpaceX launches even more rockets to the station. And another all-civilian mission, this one orbiting the moon and Earth.
Welcome, everybody, to Crew Dragon Resilience.
Jared Isaacman, the billionaire who paid for last year's St. Jude fundraising trip, is paying for 3 more space trips, a new SpaceX program dubbed Polaris.
We're going to go farther into space than humans have gone since we've last walked on the moon. We're going to test out a new spacesuit, which includes an EVA or spacewalk.
The first private astronaut spacewalk, 310 miles above Earth. Yet another billionaire, Japan's Yusaku Masawa, plans to take 8 more civilians on a SpaceX trip around the moon. Jeff Bezos and Richard Branson plan to launch more space tourists to low Earth orbit in 23, but it's Artemis and SpaceX that are forging a new path, poised to take humans to a higher orbit and eventually one day to Mars.
It's about building a permanent base. It's about building a space station that will orbit the moon. It's about getting us started in terms of having fuel depots, supply depots. It's really about building the infrastructure that we will build off of for the next 50 years, the next 100 years.
So the timeline here, NASA is hoping to orbit the moon with astronauts in 2024, landing on the moon in 25 or 26, then a moon base. They hope to go to Mars in the late 2030s, but it could take up to 9 months to get there, then 3 months on Mars, then 9 months back. So you're talking about 2 years, more or less. And you got to hope that the crew gets along well if they're going to be crammed together for that long.
Well, with that, we'll end today's Voyage to Mars. If you like the video, hit the like button and the subscribe button to get a notification every time Reaching for the Moon posts a new video. In the meantime, thank you for watching, and remember always, failure is not an option. Bye.